So if you've looked at the calendar already, you may notice that there's a few things kind of spread out. We ended last week with Unit 2, where we kind of spent 2 weeks just really talking about the front end and the UI stuff, getting you started with that, with text views and edit text and buttons, right? There's a lot more there to UI. Like hands down, there's a lot more there to UI. Contrary to what I usually do, we're doing a little bit of a transition to talking about some other context topics this week. Yes. Oh, I will fix that. Sorry about that. I am unmuted. I didn't realize that I was muted. We talked about kind of last 2 weeks, mainly around the UI standpoint. There's still more to that. We're going to take a break with that this week and next and talk about some other topics and come back to that. The reason that I'm making this transition is both from combination of student feedback from previous years that I've run it and just some things that I've noticed. So that's part of why I'm transitioning and doing something different this year. Usually the content that we're going to be talking about this week is covered kind of over the semester, but most of it is towards the last 2 weeks of class, right? Which isn't, I kind of understand why it's there. And it makes sense if you guys were, maybe this is your first programming class, then that would be a good place for it. But since this is your fourth semester, for most of you, third or fourth semester, I think it makes more sense to move some of these things forward because it's where we spend most of our time and you have some of that background and that's kind of where we want to go with it. So our kind of overall goal for this week and Unit 3 in particular is we're going to talk about how do we connect to the internet? How do we send HTTP requests, right? Which should be very familiar to everybody that was in my third semester class because we spent most of the time sending HTTP requests back and forth, right? Working with web services, working with web APIs, sending GET requests and POST requests and delete requests and put requests. So that's what we're talking about. How do we do that from Android? How do we do that from Java? How do we make those GET requests that go over to a web application and bring data back and use that in our applications? So that's kind of the overarching goal. Everybody good with that? The gotcha on the world of Android and Java is that a lot of that functionality is not really baked into the language or really the API itself, right? So in order to make that happen, we actually have to glue a bunch of pieces together. And fair forewarning, these pieces and the pieces that I've chosen to put together have changed every year I've taught this. Every year I've taught it, I've had to swap out something and put something in new. Because it's one of those areas where Google's actively making changes to the platform. Like they're doing different things and they're saying, oh, don't use this anymore. This is deprecated or even removed in some cases. And you have to move over to something else. So it's one of those things where there's been a lot of shift, and if you look at your chapter that's kind of related to this, I think 7.2 is the closest to what we'll be talking about today. Some of that information is already wrong. Some of that information is actually incorrect, and you'll get warnings in Android Studio if you try to use that code. So there's some heads up there, right? So that's part of why, if you looked at the reading material and you looked at what I've given out, I asked you rather than reading the chapter this week, reading rather related chapters, there's a bunch of articles that I've specifically called out, which has some more updated information than what is in the textbook. Cool. So those are definitely things to take a look at. Some of those are a little bit in depth. Some of them talk about things that we won't go into, so I do apologize for that. I wish that these were more beginner friendly, but that's kind of where the information is. So we'll skim over that. I want to take a look at what's in some of those to kind of point you to it and talk about what was covered. Okay. So again, we're kind of going to spread this out. This week is going to be a lot more theory heavy. I'm going to say that hands down. This week will be a lot more theory heavy than some of the previous weeks have been. The trade-off for that is I'm going to give you less hands-on work to do. Because there's more theory, we're going to do less hands-on. Does that make sense? So, and part of that is there's just a bunch of topics we need to kind of skim through, and you need to have a basic understanding for before we can get you to what I actually want you to do. So even in some of the stuff that I'm going to talk about today, today I'm really going to talk about the hard way to do things so that you understand what's going on and you understand the underlying principles. And tomorrow I'll show you the easy way to do things. Does that make sense? So that's the other side of the gotcha, is there's a bunch of ways to do this. Some ways are definitely hands down easier to do, and some ways harder. And there's also just the matter of changes and knowing a little bit about what's out there and what's happened and some of the history and some of the gotchas. Okay. So that's part of where that sits in there, is also just I want to make sure that you kind of understand the right way and the easy way to do things before I have you write a bunch of code the wrong way or the hard way. Cool? All right. So general objectives for today, and I'll post a copy of this, take a snip of this and throw it in Discord. So we're going to talk about requesting permissions. One of the things we have to go through is how do you request permissions in the manifest? And specifically, there's two permissions that we need to request: internet and network access, network state. That's a pretty easy thing. It's basically there's just two lines you need to add to manifest to make this work. And these will be things that definitely, when you see it, take a note of it, because all of the rest of your projects for this semester, you'll need to put those two lines in your manifest. Like every single project, you're going to put those two lines in your manifest. If you don't, you try to connect the internet saying you can't do this, you don't have permission. Okay, so that's one thing we'll talk about. We'll talk about permissions. We're going to look at how do we use the connectivity manager to check if there is a connection, specifically an internet connection. And because when you're working with mobile, you've got cell networks, you've got Wi-Fi networks. Those may be connected or disconnected, or you might be in airplane mode, so you have to kind of be aware of that context. So we do need to look a little bit at connectivity manager. We're also going to look at the network callback that's within there that you can use to monitor the connection. So you can actually see it change from connected to disconnected. So we'll look at an example there. I'm going to show you how to use an async task to run background work, and we'll talk about why that's necessary. But we'll look at how do we use that to create a background thread. We're going to talk a little bit about how do we split the work between the main thread and the background thread, what needs to happen on the main thread, what needs to happen on the background thread. We're going to look at also, I put an example out here. I want to talk about how to use a thread directly over rather than using this async task class. So we'll look at how we use a thread and instantiate or start a thread itself. We need to look at how do we make GET requests. So we'll be using the HTTP URL connection class for that. Sorry for the long name. That's where Java sometimes has longer names. But that's the HTTP client we'll be looking at today. We'll also look at that. We'll also talk about a little bit the buffered reader, input stream reader. How do we use those to read the response line by line? So that's one of the things we need to do is say, hey, we made the request, but then I want to see what came back. So we're going to use these readers and have to talk a little bit about I/O. And then we're also going to look at, while we're there, we're going to look at the try with resources statement, which is a relatively new thing in Java. It's very similar to the using statement in C#, but it's something that's commonly used with I/O. So I want to show you what that syntax is and where that fits in. Okay, so you might notice that there's a smattering of things here, mostly in the category of like networking and I/O, and in something called threading. Okay, some of these concepts are probably going to be new. That's okay. So if anything, if you have a question about anything, if you have any question about terminology, ask it. Today's the day to ask that because there's a lot of new terms and a lot of new concepts today. Fair forewarning, like I've got a bachelor's degree. The place in my curriculum where some of this stuff was taught was in my junior and my senior year. So some of these concepts are probably foreign. They're probably things you haven't seen yet. Trust me, they're not as hard as they may seem, but there are things that you're going to be in a better place if you know them today rather than if you know them later. So that's where we're going to be today. Okay. Questions so far? All good, right? Okay. So let's look at some of the reading material and we'll start there. So one of the first things that I had posted here is to say, look at this article called Connect to the Network. Okay. So the very first thing at the top of this article says, hey, if you want to do anything at all with network permissions, as these two lines of your manifest. See that? Uses permission, yada, yada, yada. Internet access and user permission, access network state. So where these are going to land in your manifest, the place they're going to land is above the activity tag and just below the manifest tag. Let me actually pull up my code sample. I'll tell you later how to get this, and we can look at, I can show you where that fits into my manifest. If you want to get ahead a little bit, I've got a repo here I'll be pulling a few from. I'll talk about this later about how to get it, but that's where I'm pulling this example code from. There's a few things I've built for today. So open, and I need to go here. There. Pull that up. Gotta wait for it to build. Okay. Trust the project. And still pulling the real thing. App. Okay. So in terms of the manifest, okay, we've kind of already had, every project we create already has one of these, and you might remember that. You'll see at the top here is the manifest tag, so that's the part that wraps the entire document. You'll notice that where I have the two users permission is between here, the top, the outer manifest tag, and the application tag. So it's not inside the application, it's not inside the activity, it's just kind of floating out here by itself. Cool. This is one of those very few things that you'll see outside of the application tag. Most things will be either inside of the activity or inside of the application. So what is permission? Why do we need this? Okay. Well, out of the box, right? Your Android applications are kind of operating in what we call the sandbox, right? There's a limit to what they are allowed to do, right? What they're allowed to do on your device, right? And so without permissions, you're allowed to do certain things like the things we've already done. You're allowed to have activities. You're allowed to have inputs and outputs. You're allowed to work with the keyboard. But there are a lot of things you're also not allowed to do, right? So there are various kind of grades of permissions of things you can do. There are things that you get automatically. Every app is allowed to do them without asking permissions. There are some things where you have to ask for them here in the manifest. And that just means that at install time, when the user downloads it from the Play Store, that it will ask the user for that permission at that point. Does that make sense? So if you've ever seen anything from the Play Store where it said, when you went to install it or download it from there, it said, hey, this application needs these permissions, that's why. That's because they were declared here in the manifest. Okay. So this would mean when we download it, it would say, hey, this application needs internet access and network state access. Do you want to grant it this? And they can either say yes, proceed with installing the application, or they can say no, don't install the application. Right? So that's the first two levels. Right? The next thing that happens is sometimes there are permissions, and this is a newer thing. There's been a trend towards having fewer permissions declared here, because you don't want the user to like look at that dialog as soon as they install the app and decide not to install the app, right? Usually it's better to ask for permissions later. Does that make sense? Usually it's better to ask for permissions later. So a lot of apps now, you'll see cases where you're using the application and it says, oh, I need access to your location. You want to give me access to the location. So we can actually ask in the application for that permission. Once you grant that permission, it's got it permanently. Okay, but you can go back. You can go back into the settings and take it out, or change what permissions each app has. Okay, so there's those different levels. You can either have, these are the things that every app is allowed to do. These are the manifest declared permissions, or you have runtime permissions, which is where you ask at runtime. There's another tier of permissions where most apps aren't even allowed to do those things. There's another tier of permissions where, in order to get permission to do that, you have to be a system level app, right? You have to be installed by the manufacturer of that device. So things like, hey, you've got these apps that were shipped with your Samsung tablet. They are system level apps because they were pre-installed. And actually, system level apps you can't uninstall. But they have access to some elevated permissions that they can declare here. Cool? So that's just one thing to recognize when you're looking at the docs, when you're looking at permissions. If it says system level access, basically your app doesn't have access to that. It's not something you can do. It just, there's a brick wall, because that would be dangerous. So that includes sometimes things like seeing information about your SIM card, etc. There are some things in there in terms of the related working with Wi-Fi and some other things there that are more higher level. Okay, so that's that. So these two permissions appear here. These are the way that we're going to ask for internet permission. Okay, which kind of makes sense, right? We want to build an app, and what we're talking about here is building an app that requires internet to function, right? If you don't give this app internet access, then there's no use in installing, right? There's no use in installing it if you don't want to give it internet access. Originally, actually, and I mentioned that, permissions, when you declare them here, are permissions that are requested when you install it from the Play Store, right? You might notice if I install it from Android Studio, it doesn't ask for any of these. So these are not, when you just install something through Android Studio, you're just putting the package in, it doesn't ask. Okay, but the Play Store does ask. It turns out that these two permissions, virtually every app needs, right? Almost every application needs access to the internet. There are very few applications that can work completely offline, right? So originally the Play Store asked for these. Over time, Google decided, oh, this is really annoying to have every single app ask for internet permission. So actually modern apps, if I were to install this from the Play Store today, it wouldn't ask me about those two. It would just go ahead and install. So it used to prompt about those two, but those two are on the basically you get them for free, you just have to ask, right? You don't get them if you don't ask, but you're going to get them automatically. Okay, so they're in kind of a weird state, and that's where they don't follow the normal rule of asking for permission. Cool. Any questions about that? That's basically, as far as I know, those are really the only two permissions we're going to talk about in this class. There are a whole bunch of other permissions, but these are the only two that we need to do what we're covering here. Okay? So you can read further on that, but that's as far as we're going with permissions, is just to add those two. Next up, looking back further down through the document. you'll immediately get down to here, and they'll kind of say here, these permissions are normal permissions, and so that's why we're doing it this way. So there's a little bit of mention about that. There's a section here you should have read through, best practices for secure network communication. So there are some kind of recommendations in terms of things we always want to do if we're accessing the network. We want to minimize the amount of sensitive or personal user data that we send across. Why is that important? Why do we need to minimize the personal information we're sending across the network? How often is your mobile device on an unsecure network?
Anytime you're not at home.
Huh?
Anytime you're not at home.
You're close. Is your device on a trusted network if you're at home?
It may or may not be.
May or may not be. Why?
But some people don't use Wi-Fi.
Okay. So if and even if you are connected to the Wi-Fi, the device may still choose to use your cellular connection, right? So you might be using a cellular connection, you might be using a Wi-Fi connection. At home, usually we kind of trust our Wi-Fi connections. We don't usually trust our Wi-Fi networks outside of the home space. So you might be at Starbucks, you might be at the library, you might be somewhere else, you might be here, right? And maybe you don't trust all of the other devices on the network. Everybody else is bringing, you've got all these students bringing in their own phones and their own phones and their own laptops. Who knows what malicious software is on there, right? There could be viruses, there could be other things that are looking and scanning the network and looking at your traffic, right? You don't want that information to be just out there and visible for anybody that's in the area that can see your network. Does that make sense? So in large and part, even in the home case, we generally would assume that, the network's not safe. We can't trust whoever it might be looking at the network. So we want to be careful and extra careful about who's there. If you're on your laptop and you're on a work network, or you're on your desktop or whatever, and you're on your home network, usually we're a little bit more lax about that because we kind of inherently trust either our employer or we trust our home network to be safe and not have malicious code running and whatnot, or we trust our internet service provider to not be spying on us. But that really isn't the case in the mobile space. You have to really assume in the mobile space that everybody wants to spy on you all the time, because they do. I hate to say. So we have to be very careful about what we send in the first place. Okay. So that means, if we are going to send private information, we pay extra careful attention to it, but usually we avoid sending it entirely when we can. The next thing that's important is really, really critical to send all our data over SSL. That's a non-optional thing. That's a non-optional thing when it comes to building for Android. You don't send anything over, say, HTTP, period. Never. Because it's just too much of a security risk. It is possible. It's actually in Android today. If you want to send something over HTTP, you actually have to change a setting in the manifest to allow unsecure requests. But then that's application-wide. So out of the box, actually, if you try to make an HTTP request, it is just straight up denied. So only HTTPS requests are allowed through. That means, for instance, if we're building a web application and we want to connect that web application that we built to our mobile app, it needs to be served over HTTPS. If the API isn't served over HTTPS, it's not safe to talk to it from Android. Cool? So that's a basic requirement, that whatever you're connecting to needs to be HTTPS, not HTTP, but HTTPS. Because that provides a certain level of encryption. And remember, that comes back to the idea of there's other actors watching your network that you may not trust. And if you don't use SSL, you're not using encryption, you don't really have any protection. You really don't have any protection if SSL is not. The next thing And they kind of mentioned talking about a network security configuration. This is honestly a level that I'm not so familiar with. It's a little bit beyond me, but they do mention that for trusting certificate authorities. CAs, that's what that's what we're talking about here. Where that fits in is related to SSL. So anytime you have an SSL connection, you have a certificate that kind of proves that you're actually the right person, that you actually have the right encryption keys. And so for one of the things for SSL to work is you have to have that certificate. You have to have a certificate authority say that that certificate is valid. And so you may want to limit who can grant that certificate of authority. That is basically around if you let anybody to sign the certificate, then you can't trust that your server is actually your server. It might be somebody else's server impersonating your server, right? So that's why you really care about the CAs, because otherwise they can be impersonated. So that's walking things down further than we really will go into this semester, but it's a really important thing in terms of security. Cool. It's a bit further than where we want to go here. Okay. Next thing you want to do is you do have to go through and choose an HTTP client, right? What client are you going to use to talk to the server? And when we're doing things with React, that was a really easy answer, right? It was a relatively easy answer because there aren't that many options. In the web world, there's either the Fetch API or there's the XHTTP, whatever API. There's two underlying APIs in the web world that you can use, and then everything else is just like a library on top of that. So we used Axios in particular last semester to work with our REST servers. In the Android world, this is probably one of the harder things to figure out because there's a lot of history to it. So originally, kind of walking back, right, Java's been around for how many years? Mid-90s, right? It actually turned out that roughly, in the mid-90s when Java originally came on the scene, the internet networking was pretty new. It was pretty new. So there wasn't most languages out there and most programs out there weren't doing too much with the network yet. Okay, but Java was there kind of on the wave where applications you want to building applications that connect to the internet, so they got ahead a little bit on that game. They're actually having, I would say that the APIs for working with networking in Java versus working with C++ was actually easier to do it, and hands down easier to do it in Java. Because the other side of things is all of those levels at the C++ level, all the APIs at C++ level were different from operating system to operating system to operating system. If you want to go over the network using C++, it was one thing in Linux, a completely different API in Mac, and a completely another API for Windows. So you'd have to build 3 different versions of your code to work on those different operating systems. It was really a pain. So Java came along and said, hey, we're going to build something, the objective is write once, run anywhere. So here's an API that you can use to work on any operating system. So Java starts out with an API that works on Linux and Mac and Windows, and it's all the same API, which is great. Okay. Unfortunately, the web moved a lot faster than Java did from that point. And at this point, the APIs in JavaScript are much, much better than the APIs in Java, hands down. The Fetch API or Axios, those are significantly better than what Java has. And so that's one thing to kind of recognize there. The other side of things is when Android originally shipped, the standard Java APIs were actually basically broken. For all intents and purposes, they were broken to the point of being unusable, unfortunately. So when you're talking about the original like Android 1.1.0 and Pro 2.0, using just, hey, here's the API that's built into Java wasn't an option. Okay, so what do? Well, we can't use the API that's built in to make HTTP requests. We use somebody else's API, right? Use somebody else's API. So at the time, right, one of the really popular open source companies out there, open source groups, was a group called Apache. Apache is really cool. They're still around. They're really known for making the Apache HTTP server. But they also contributed code and libraries for Java. Large in part, I'd say the Apache Java libraries have really fallen out of favor, but they were really popular for a time. To the point that early on, what Android did was actually shipped with the Apache libraries. They actually shipped with the Apache HTTP client class. So if you go right now and you go to the Android developers page and you look up for, say, HTTP client or HTTP request, and start with HTTP request, enter. Okay. You might even know what's the top result that comes out. org.apache.http.http request, right? Let's click on that link though. Well, that's interesting. Now deprecated, all the documentation is gone. So this, that's one class there. You notice that's under org.apache. Look for HTTP client. And there's some mentions about things changing in Android 6.0. You notice that HTTP client also deprecated documentations. So it used to be in the early days, and actually when I was doing Android professionally, those were the classes we used. We used HTTP client, right? That was my original introduction to doing this stuff, doing web requests, was we were using HTTP client. Unfortunately, they shipped this really early, and it turns out it was an older version of the HTTP client because since the time they baked it in, Google decided to kind of bake it into Android, and then it continued to be updated, but not updated in the Android space. Okay. Well, long story short, you can see at some point it's been removed. So it used to be the thing we use. We can't use it at all anymore, right? If you try to use that in a modern Android device, it's gone. Okay. So if you're trying to do reading on this, just that's one heads up. If you see anything referring to org.apache, forget it. It's old. It's gone. Okay. So that's one option that used to be out there, is we could use HTTP client. There also was a similar class called Android HTTP client, and we can still look that up. And you see it's android.net HTTP Android.client. Okay. This used to be a subclass that was specifically built for Android. Same story, it's gone, right? Okay, so what happened, right? So you notice that the APIs that we used to use, the first sort of APIs are gone. What's the new thing that we use? Well, what happened at some point, basically, remember I said that the built-in API shipped as broken. So because it shipped as broken, we had to use this thing instead. A few years down the road, let me look up HTTP URL connection. This class, which has been actually in Java for a very long time, is the kind of the Java standard way of making connections, making HTTP connections. So this dates back, I think, even all the way to like Java 2.0. This is the new way where we're going now as far as how do you connect, right? This has been the thing that's kind of replaced it. There is a note down here, just looking at the histories. avoiding bugs in early releases, Chromio 2.2, yeah, there were some issues. So they kind of allude to some of those issues. If I remember right, it was a little bit more than what they're mentioning here. But that's part of where the history was, right? Is so because of those early versions, we couldn't use this yet. But those versions are kind of in the distant past, right? Is the good news is those versions where we could use HPURL connection are basically dead. Okay, so this is what's taken over, and I guess it was around 6.0 or so. Android finally said, okay, stop using the Apache client, use this client instead. Okay, and which is kind of good, right? It gets us back to writing more standard Java instead of writing like Android specific Java, if that makes sense, which is helpful. So that means it's easier to share things between different applications, etc. So this is the newer way of doing things. Okay. Now I think I will come back to this. So this is one option there. That's the option that we'll be pursuing today. Is we'll be looking at that particular HTTP client. Is how do we use this HB URL connection class? There's some other options out there, which I just want to throw out there so you know. There are some third-party libraries that have been built on top of both the old Apache client as well as the new HB URL connection class. In addition to, there's another one coming in to kind of replace the HB connection, which I'm not fully understanding. But there's a new thing called ProNet, which is a third API coming down the road, which also means that the stuff we're going to talk about here is going. We know it's likely going to be replaced by this ProNet thing. So Volley is an option out there. Volley is a HB library that's built and created by Google themselves. That's their option that they put out on the market. It's pretty good. It actually does make things pretty simple, but it's fallen a little bit out of support, is what I will say. I think that Google's kind of dropped the ball. I don't think that they've really made changes to it in the past recent years. And I can give them credit for the fact that they've really kind of stepped aside to let another option come about and become more popular. So you might know this company called Square, right? You've probably used their checkout system before. Well, they actually have had a long history of contributing code and libraries and things for working with Java and working with Android. So they've actually have some really solid libraries and tools that they've just made there publicly available to anybody that wants to use them. We'll be talking about two of those this week. One of those is Retrofit, and the other one is Picasso. They're really, really solid. Honestly, really, really solid, and they're really better, I think, than anything Google's been able to produce. So those are some of the options there, right? So backtracking, talking a little bit about what our options were. Originally, it was HTTP client. We've got, that was kind of the first thing. We've got HTTP URL connection was the next thing. There's something coming down the pipe called ProNet, which I won't be talking about here. There is Volley, which is created by Google, and then there is Retrofit, which is created by Square. Okay. So we've got Apache, we've got Java, created by Sun. We've got, this is an Android specific thing, ProNet. We've got Volley is created by Google. And we've got Retrofit created by Square, right? So there are a lot of options, right? That's just the 5 most popular options. But really, anybody that wants to can create their own variation of these HTTP libraries. So by no means is this all of the options out there. These are just the most popular options that I am aware of. Okay, so retrofit is the kind of the newest entrance into the third-party space. Again, we'll be talking about that. My goal is to talk about that tomorrow. And that's where I say we're going to talk about the hard way today and the easy way tomorrow. So the hard way today is working with HTTP URL connection. The easy way tomorrow is working with retrofit. Cool? Okay. So just talking about a little bit what's in there. I don't think we need to necessarily talk about DNS per se. They mention a little bit here, so if you've read through this, you've gotten maybe a preview of this idea of a repository and service kind of thing that they're doing with retrofit, but I'm not going to focus too much about all of this here. But it does allude to some of the stuff of where we're going. I'm just not going to start there, if that makes sense. Right, so when we get done, our code will look a lot closer to what we have in these other examples, but there's a lot of kind of foundation that I need to set, I think, before we get here. Cool? Cool. One downside that I see, with following the documentation is a lot of these things like this kind of presume that you have other knowledge, like you know about retrofit, you know about view models, you know about live data, but obviously we don't have that information yet. So we're going to have to kind of put the puzzle pieces together as we get them. Okay, so our basic understanding, what we need to understand is we're going to be using that to request for network access, and then what we will be using is HTTP URL connection to actually make that request happen. Okay. So let's take a closer look at this class. Let's take a closer look at what is in HTTP URL connection. Sometimes the relevant information, you will find it in a guide. Sometimes the relevant information for how to do something is actually in what we call the class header for that particular class. And in this case, we're going to look at the HTTP URL connection class. Okay, so I'm going to expand this out, make it maybe easier to see if it will fall down nicely. There we go, 175%. Okay, so looking at what this class is. So a URL connection with support for HTTP-specific features. It says see the spec for details. That basically says here's the spec. If you follow that link, it's the spec for what is HTTP, which we kind of have an understanding of, hopefully already. So in terms of using this class, they give you some tips about how do we want to write the code. So first we need to, as they say, open a connection and cast the result to HTTP URL connection, right? So the first step is we say, call this URL class. It's actually a static method. We say URL.open connection. This is what we call a factory method. Factory method because call that method and it gives you another object, instructs another object. And so basically, in order actually for you to get a connection in the first place, you actually have to have a URL. Actually, it's not static, it's an instance method. You have to have an object first. So step one, make a URL. You actually have to make a URL object. From there, we call open connection on it. And then, because open connection actually returns just a URL connection, which is the base class, we need to downcast it to HTTP URL connection. You notice here, subclass, you can see it's a subclass of URL connection. Okay, this gets interesting. Next up, step two, they say prepare the request The primary property of the request is its URI, so we've kind of gotten that part started. Request header may also be included metadata such as credentials, what content type do we want sent back, specifically we're usually wanting JSON back, and any cookies that we might need to be sending to keep track of your, say, login session or other things. Okay, so those things we have to add to the request. If it's a post request, you may need to upload a body. So they kind of mention here, set do output, yada yada, working with this output string. Finally, once you've made all that request, then you start to read the response. Last thing you have to remember to do is disconnect. Now that step 5 is a really, really important one. That step 5, especially in the Android world, is super, super important. It's an easy one to forget that you need to disconnect, and it's an easy one to do wrong. Okay. The gotcha there is if you don't disconnect, that connection will, and those resources associated with the connection will be kept up indefinitely. They'll be kept up for the lifetime of your application. If it's a small application, no big deal, right? But once we get to larger things and we're making hundreds of HTTP requests within a single session, and the user may have this device open for a week, the app open for a week or more, you don't want that to accrue hundreds of open connections that haven't been cleaned up. Does that make sense? Because there's actually a hard limit of how many connections you can keep open before your application crashes. So if you don't disconnect, and if you don't consistently disconnect everywhere, you will eventually have your application crash. And it will be when your user's trying to make any sort of HTTP connection, right? That's not going to be an ideal place to be. It might be when they're checking out. It might be when they're trying to register their account. It might be when they're trying to look at your list of products. Who knows when that's going to be, but we don't want that to happen, okay? So we have to be very diligent about making sure that we disconnect anywhere we make a request. Cool? I'll show you the pattern that we follow for how do we make sure that that disconnect happens. And it's very, very important that if you're working with this code, if you're working with the HTTP to URL connection, that you follow exactly that pattern. There's a reason why it has to be that way, okay? So that's the general overview, okay? So if we look down further, here's a code example of putting this place into play. First up, you'll see that they have a URL object, okay? So we say, okay, let's create a new URL, and it's taking a string, right? So they've hard-coded in the string here, www.android.com, right? So you start with string representation of your URL. You construct a URL object from that string. Is everybody good with that? In that construction process is where it actually parses the URL, right? When I say new URL, it's going to parse the data that's in there. If it's an invalid URL, at that point, that actually throws an exception. Specifically, this here is going to throw a malformed URL exception if it's not a valid URL. Everybody clear with that? Going to throw a malformed URL exception. So that in and itself can throw an exception, which usually means if this could throw an exception, what do we have to do? We have to catch it, right? So somewhere at some point, this has got to be in the try, right? This whole thing actually has to be in a try, okay? They have a try here, but I usually write it a little bit different because I need the whole thing in. So that part can go wrong. The next thing we do is we say URL connection equals this URL.open connection, right? So URL.open connection says, okay, we've got this URL, give me a connection to that URL. Now, it returns a URL connection because we don't know what kind of URL that might be, right? We don't know if that's an FTP URL. We don't know if that's an HTTP or an HTTPS URL or any other kind of URL that it could be, right? There's a lot of kinds of URLs out there. Does that make sense to everybody? Right, the protocol could be anything. Now, only if the URL starts with either HTTP or HTTPS, will we get back an HTTP URL connection. Only if that's the case. Okay. So here we're making that assumption because we know what the user URL is. If we have the user typing in that URL, you got to check, right? So this actually can throw an exception if that doesn't start with HTTP. That's another heads up. There's a lot of places where this throws an exception. So we start with that. Next thing they do is they go down here and we're starting to read the response, okay? So they say URL connection.get input stream, okay? Get input stream. That's where we're going to read the response out. In the world of Java, in the world of I/O, Java has this interesting sort of terminology in the way it works with input and output. It is similar. It is similar to some of the ways that C# works. C# has the ideas of streams and readers and writers, and they do agree on some things, but there are some places where they've gone a little bit of a different direction. Okay, so an input stream, right, is a binary buffer, effectively, a binary buffer of data that you can read in from wherever, right? So we're talking about input streams in the Java world. They could be coming from files. You could get an input stream from a file. You could get it from here's a network request that we're making, or it could be from Bluetooth. It could be from anything else. But generally, input streams are from outside of your application, where you're asking the hardware to do something and you're bringing it back in to your system. Okay, that's the general thing. So the most common places where most Java developers see this first is in reading a file. If I'm going to read a file, I open an input stream or a file input stream to that file. But here we're opening it on that connection. Cool. So that's going to give us a series of bytes. Okay. Next thing you'll see is we wrap that, we take that result, we take the input stream and we immediately wrap it in another class. We say new buffered input stream. New buffered input stream. Okay. What this does is it basically adds a buffer. The API of input stream says at any point in time you can say, give me the next X bytes, and it will give you the next X bytes. This just adds a layer. It actually makes it more efficient, right? Adding that buffer means that, okay, it can kind of read things, put it in the buffer, and then when you ask for it, it kind of pulls it out of that buffer. So I don't want to get too much into the weeds there, but suffice to say, we always want to buffer our inputs in some way, shape, or form. So sometimes we do that with a buffered reader, sometimes we do that with a buffered stream. But it's always more efficient to use a buffer in there. And then they're calling this method readStreamIn. Now, readStreamIn is a method that they have written. It's not built into the platform, and they don't show it to us, unfortunately, right? But we need to know what's there, right? So you'll see that in the example. And then finally, when they're done with this, you'll notice that they disconnect. They close the connection in the final clause. Okay. Why are they disconnecting in the final clause?
Always want to disconnect whether to try.
Correct, right? So one of the things to remember with, and this is a kind of weirdness, your try will go until there's an exception. At which point there's an exception, it will stop what's in the try and go over to the catch. Okay, so if you put a line of code in the try, it's not guaranteed to run, right? If you put some code in the catch, it's only going to get run if there's that exception. Or, well, what happens if there's an exception in your catch? Because that can happen too, right? You can have your catch and you have an error and a bug in your catch. That throws an exception. Where did your cleanup code go? Right? So remember I said it's very important that we always disconnect, okay? So what finally does is it gives us guarantees. Finally is all about guaranteeing that something happens. So finally guarantees that regardless of whether or not there was an exception in the try, and regardless of whether or not we hit any catches, and regardless of whether those catches threw exceptions, we will always run this line of code, period. After all of the tries and all the catches, we will run this code. We guarantee that for you, right? We guarantee that we will do this cleanup, which is exactly what we want, right? It guarantees no matter what mistakes I've made above, this will happen. Is that cool? It's one of those cases and one of those clauses, finally, is one of those things that you don't necessarily maybe have used much up until this point, but is really, really important for RAO and is really important for this kind of operation. Cool? Okay. So they do so. Let's see if there's anything else in there we need to mention. I'm going to leave that. Yeah. One thing I might mention in terms of the performance side is they do mention here the input and the output streams for posting data and retrieving the result. But these are not buffered, so you want to make sure that when you're reading from them or posting to them, you generally need to use some sort of buffer, whether that be buffered input stream or buffered output stream. Usually one. Okay. So we usually need to have a buffer. Other than that, let's kind of track back and let's start looking at some of the code. So we've kind of seen an intro there. What I want you to do is we'll kind of take a quick break here. You're going to go out to this example code repo that I have. I think it's posted both. I've added it to the reading material. I've added it to my notes. I'll go ahead and add a copy into the Discord. What you'll want to do is go ahead and clone this repository, pull it down. I've got 5 code examples in here, and we're going to walk through them kind of one by one, right? This is kind of going to iterate towards where we're going. So go ahead and go to the code here. And go to that drop down. You're going to copy it, or you can go open with GitHub Desktop. Either one of those is fine.